In this segment, we're going to describe the architecture of Apache Kafka. This first slide shows the overall high-level architecture of a Kafka cluster with producers and consumers. You would typically implement some sort of producer that's responsible for sending messages to the Kafka cluster, and then you'd have a consumer that's responsible for reading messages from the Kafka cluster. As we dig into that a little bit deeper, we talked in the first segment about partitions, and there's topics as well. Remember, Kafka is a messaging system reimagined as a commit log service. As this, a key piece of the Kafka terminology is a topic, which is really just a name you want to give to a series of messages. So let's imagine we have this topic and it has 3 partitions. As you write data to it, Kafka uses a write-ahead log and is writing data going forward. Okay, so it's writing ahead. So you'd see the old data, the back, and the new data at the beginning. So it's a write-ahead log, and it would be split across multiple partitions. Another essential piece to the architecture of Kafka is Zookeeper. Kafka does today require Apache Zookeeper. It's used for storing configuration data for Kafka as well as many other distributed services. Most often, it is used by the brokers. In the 0.8 versions of Kafka, the consumers are still using Zookeeper to store information such as offsets as to where they're reading in the Kafka topics. In the 0.9 version of Kafka, the clients are changed so that they store offset information in Kafka. So now they no longer have to rely on Zookeeper for storing offset information. Let's take another look at the Kafka cluster architecture. This time we've exploded what that cluster looks like. So again, we have the producer that's sending messages as Kafka cluster and a consumer that's reading them. And you'll see here is that this Kafka cluster composed of brokers 1, 2, and 3. In the previous slide we mentioned a broker. You think about a broker just being an instance of Kafka running on a server. And that is really the broker. And that terminology stems from the messaging system background of being like a messaging broker. And you see as part of this, you also have Zookeeper. Now this slide ties together the notion of the Kafka cluster with the partitions. We're also introducing a new concept here that's called these consumer groups. So let's take a look at how this works. So if I have a Kafka cluster and there's 2 servers, there should be 2 brokers, and we have 4 partitions for this topic called partition 0, 1, 2, and 3. So data is going to get written to all 4 of those partitions. Now when you go to consume data, the way Kafka helps with parallelism is this notion of a consumer group. And Kafka's guarantee is that all the consumers in a group, so the consumer group, will get a chance to read all the messages for a topic. Not that a particular consumer in the group will, unless you had a consumer group of 1, but that the entire consumer group. So therefore, you could go from a consumer group composed of 2 nodes to perhaps a consumer group composed of 4 nodes, and you'll be able to keep adding consumers to increase the parallelism by which you could read data. So in this case, we have consumer group A that has 2 consumers. And we're just going to say, for instance, that consumer 1 was getting data from partition 0 and partition 3. And consumer 2 was getting data from partition 1 and partition 2. In this other example here of consumer group B, now we have 4 consumers as part of the consumer group, and each one is going to read from a partition. So in both cases, the consumer group in its entirety is consuming all the data for a topic. Okay? And you can see here the difference between 2 consumers in a group and 4 is the amount of data being read by each consumer. So that's the high-level architecture of Apache Kafka. And we're again going to go into each of these aspects of it in greater detail as this course unfolds.